today we are talking about polynomial inequalities. Okay, before we get into it, I would like to do a quick review of something extremely similar, which we have already talked about this semester, quadratic inequalities. As we know, quadratics are just very specific polynomials, right? Polynomials with degree 2. So our polynomial inequalities are actually going to be very similar to quadratic inequalities, just with higher degrees. So let's look at an example of a quadratic inequality. Let's say we're given x squared minus 7x is greater than or equal to negative 10. So let's recall our first step was, as is usual for quadratics, even with equations, to bring everything to one side. So we have x squared minus 7x plus 10 is greater than or equal to 0, right? We wanted this greater than or equal to 0 so that we could use the roots of the function to tell whether we're greater than or equal to 0 at a given point. So what are the roots of this function? Well, we can factor to figure them out. So we want something that adds up to negative 7 and multiplies to positive 10. Sounds like that's going to be x minus 5 and x minus 2. Still greater than or equal to 0. Now we use that to find our roots. Of course, this means that we have a root of 5, and this means that we have a root of 2. What do we do with those roots? Well, we definitely want to put them on a number line. So we have 2 and 5. What was the purpose of this number line? Well, it was to record where we were positive or negative, right? Where we were greater than or less than 0. The reason we're looking at our roots is because in order to change from being positive to being negative, or vice versa, we have to pass through the x-axis. And these are the only points on the graph where we pass through the x-axis, right? These are the points on the graph where we're equal to 0. Do we want to include our roots or not? What were our rules there? Well, we included them when we were asking for greater than or equal to or less than or equal to, right? It was the or equal to, right? Because the value of the function at these points is 0. So since we can include because of that or equal to, we will include these points here. Now, we want to check to see whether we are positive or negative at each of these intervals. Let's check this interval, right? So between negative infinity to 2. What is something that's between negative infinity and 2? Well, something easy to start with is 0. What happens if I plug in 0 into this function? Well, I can plug it into either of these two, right? These are the same expression, just factored, right? This one's factored, this one's not. So I can plug it into either. I'm going to plug it into this one because that's going to make this term go away, right? 0 squared is 0. It's going to make this term go away because 7 times 0 is 0. And then we just have 10. So this is 10. 10 is positive, so there's a plus sign here. What can we pick that's between 2 and 5? Well, I'm going to go ahead and pick something easy like 3. If I plug in 3, I'm going to plug it into this one this time. I have 3 minus 5 and 3 minus 2. That's a negative number times a positive number. Negative times a positive is negative. Last but not least, we've got this. So we can choose x equals 6. I plug in 6 to my function. I have 6 minus 5. And 6 minus 2. I have a positive number times a positive number. That's going to give me a positive number. Well, again, we're asking when is this function, whatever it is, right, greater than or equal to 0? Well, are positive or negative numbers greater than or equal to 0? Positive. So let's shade in those positive intervals, right? The intervals that we marked as positive. That's those two. So now we have shaded all of the x values where this function, right, x squared minus 7x plus 10, also known as x minus 5 times x minus 2, is greater than or equal to 0. So those are all of the x values that satisfy this inequality, and that's our answer. Let's go ahead and write it in interval notation. We're starting at negative infinity, continuing all the way to 2, including 2, taking this short break, right, because it's negative here, then starting up again at 5, and then continuing all the way to infinity. That's the answer. So that's a quick refresher on quadratic inequalities. Polynomial inequalities, I'll say it again, are exactly like quadratic inequalities. Just with more factors. Let's start off with one that's pretty easy. Already factored, all that stuff. Let's say we're given 2 times x minus 1 squared times x plus 3 times x minus 2 is less than 0. Again, we know we're still doing an inequality, so we're going to want to draw our number line. I'm going to go ahead and do that really quickly. And what were the things that went on the number line? Well, it was our roots, right? Because we were trying to figure out where we're passing through 0, right? Where the value of the function is 0. Those are our roots. So let's kind of collect all of our roots really quickly. This function has a root of 1, right? And it actually has 2 roots of 1, right? The multiplicity is 2 because we have that exponent of 2. So that shows up twice. Then we have a root of negative 3, and then a root of 2. Let's put these on the number line. Of course, we need to put them in increasing order. So negative 3 comes first over here. Then we have 1, and then 2. Next thing we want to do is test our intervals, right? So let's look at this first one. We want to pick a number that's between negative infinity and negative 3. A pretty good one that fits that description is probably negative 4. We want to figure out whether this part of the function, right, is positive or negative when we plug in negative 4 for x. I'm going to put these over here because this is a long polynomial, right? So let's say we've got x equals negative 4. So that means we've got 2 times negative 4 minus 1 squared times negative 4 plus 3 times negative 4 minus 2. Again, as always, we just need to think about, we don't need to find the actual number, we just need to think about whether it's going to be positive or negative. So we're going to have here a negative number, but it's going to be squared, right? Any real number squared is positive. Then we have a negative number and a negative number. So we have positive, negative times negative, so it's going to be positive. All right, next number up, pretty good number between negative 3 and 1. I always like to choose 0 whenever I can. So x equals 0 is going to give us 2 times 0 minus 1 squared, 0 plus 3, 0 minus 2. Again, we get a negative here, but it's squared, so it's going to be positive. We have a positive times a negative. 2 positives and 1 negative is going to be negative. If you don't feel super comfortable sort of thinking through what would give us a positive or a negative number, you're always, of course, welcome to plug it into the calculator. Although just thinking about the signs might be time saving for you if you do feel pretty comfortable with that. So here we have 1 and 2, so we need to pick something between. We've been picking integers so far, but it's totally okay for us to pick a decimal. Let's pick 1.5. So 1.5, if I plug that in, I have 2 times 1.5 minus 1 squared times 1.5 plus 3 times 1.5 minus 2. I get positive, positive, negative. Positive, positive, negative gives me a negative again. Last but not least, we have 2. Here, we want to pick something between 2 and positive infinity, so I'm going to pick 3. If I plug in x equals 3, I have 2 times 3 minus 1 squared times 3 plus 3 times 3 minus 2. This is positive, and this is positive. So we have a positive here. Before we shade, let's figure out whether we want to include or exclude our roots. It's asking where we're less than 0, so it's not including 0 this time, right? It's not or equal to 0. So we are going to have open points. We don't want to include where the function is equal to 0. That's the meaning of a root, is that it's where the function is equal to 0, so it's open. Where are we going to shade? Well, we're asking for less than 0. Is positive or negative less than 0? Negative, right? So what's shaded are all of the x values that make this statement true. So all that's left is to write it in interval notation. So we're starting at -3, not included, continuing all the way to 1. We don't want to include 1, but we want to start right back up after 1. So we have parentheses, 1, all the way to 2, and then close parentheses. And that is our answer. Okay, let's go ahead and open up the lab manual to the Polynomial Inequalities section. I'd like to do a couple of these together, and then I'd like to have y'all do a couple of these on your own. So I'd like to start off actually looking at number 3. We do have less than or equal to 0, right? So everything is on one side, but we're not fully factored. So what do we need to do? We just need to factor first, right? So, right, if I just take a look at this first quadratic, I need to think of something that adds up to 6 and multiplies to positive 9. Sounds a whole lot like x plus 3 and x plus 3. If I have x squared minus 5x minus 6, I need to think of something that multiplies up to -6 and adds up to -5. Maybe -6 and positive 1. So all of that is still less than or equal to 0. Let's go ahead and draw our number line. What are the roots here? Well, it looks like we have a -3, a second -3, a positive 6, and a -1. All of these need to go on my number line. So -3 is the smallest, then -1, and then positive 6. Am I going to include or exclude these roots? Well, we have less than or equal to 0. Remember, we're trying to record where we're positive or negative, so since we're allowed to be equal to, we do want to include all of these. We want to include these roots. Now, all that's left is to test each of the intervals. So let's test x equals -4, x equals -2, x equals 0, and x equals 7. If we plug in -4, we get negative 4 plus 3 squared. I'm going to write that as squared, right, because we have these two. Then negative 4 minus 6, and negative 4 plus 1. So I have a negative number here, but it's squared, so it's positive. Then I have a negative and a negative. So we have positive, negative, negative. Two negatives make a positive. Let's check negative 2. I've got negative 2 plus 3 squared, negative 2 minus 6, and negative 2 plus 1. Looks like I've got a positive squared, so it's still positive. Then a negative and a negative. Again, two negatives make a positive. If I plug in x equals 0, I get 0 plus 3 squared times 0 minus 6 times 0 plus 1. So I get a positive, a negative, and a positive. One negative is negative. And last but not least, I plug in 7. I have 7 plus 3 squared times 7 minus 6 times 7 plus 1. I get a positive, and a positive. So 3 positives is very positive. Now we want to shade. What are we looking for? Well, we're looking for where we're less than or equal to 0. Less than or equal to 0 is negative, so I'm going to shade right here. We want to write this in interval notation. So I have closed points, which means I'm going to have brackets. So bracket negative 1 to 6 bracket. Is this all? Are these all of the x values where we're less than or equal to 0? It's not, right? We also have negative 3 where the function is equal to 0, right? If I plug in negative 3, I have negative 3 plus 3, actually twice. So I have 0 times whatever else, doesn't matter. 0 times anything is 0. So this is equal to 0, so this is included. How do we include a single number with an interval? We write it in curly brackets. That was something we didn't have to do very frequently from Module 1, but it was something that we learned, so it's good to refresh on that. Why don't you guys give this one a shot? Again, this is one that we'll have to factor, and I would just say, think about common factors that we have and what we do in that situation. Okay, so again, for this one, we factored. We could factor out a nice quadratic. We could factor out x squared, right, from each term. So our function looks like this, right, x squared and then x minus 1. We have the roots 0, 0, and 1. We put those on our number line. We have filled in points, right, because we have greater than or equal to 0. We test all of those points. We end up with negative, negative, positive. Because we have a negative and a negative right next to each other, but we are including 0, that means we shade in our positive parts, right, because we're looking for greater than or equal to. Because we have a negative and a negative right next to each other, we need to kind of include this point that's off on its own, and we do that with curly brackets, and this is the answer we get. Okay, I want to come down here to this very last one. We have x to the 4th minus 17x squared plus 20 is greater than 4. First things first, we want to bring everything over to one side. So we end up with x to the 4th minus 17x squared plus 16, right? We subtract 4 from both sides, is greater than 0. We want to find our roots. Remember, this is one of those functions that looks like a quadratic, right? But we have those kind of double exponents. So remember, we can think about this as x squared squared, right? Minus 17x squared plus 16, which looks a whole lot like a quadratic. And we can kind of factor it, right? Sort of in a similar way. So let's say we're thinking about this, again, these are not equal, but we're thinking about this as if it were x squared minus 17x plus 16. How would we factor this? 16. Well, something that adds up to negative 17 and multiplies to positive 16 is x minus 16 and x minus 1. Well, if we know that this is equal to this, and we know we had x squared squared and x squared here, right? They look exactly the same. Then we know that we can kind of, right, convert this back so that it looks like this, right? So instead of having x, we have x squared. So we have x squared minus 16 times x squared minus 1, right, is greater than 0. How can we factor these? So we've gotten a little bit closer to being done factoring, right? These are both difference of squares. So if I factor each of these into linear factors, I end up getting x minus 4 times x plus 4, right, for the first one, times x minus 1 times x plus 1 is all greater than 0. Which means that I have what roots? Well, positive 4, negative 4, positive 1, and negative 1. So I put all of those on the number line. Negative 4, negative 1, positive 1, positive 4. They're all going to have open points, right? Because we are strictly greater than, right? Not or equal to. I want to test each of these numbers. In order to kind of save time, I'm just going to go ahead and tell you guys that it's actually just positive, negative, positive, negative, positive. And we are greater than 0, so we shade in the positives. So our final answer here, I'm going to write it up here. So we have negative infinity to negative 4, then negative 1 to 1, and then 4 to infinity. Okay, why don't you guys try this one above, right? 2x cubed is greater than 8x. Pause the video, work it out, and check your answer with what I have when we are back. Remember that to start off, we always want to bring everything to one side, right? Because we need to have 0 on one side. So, pause the video. We'll be back in a sec. Okay, so for this one, we can factor out both 2, right? Both of these terms are divisible by 2, and also x. When we do that, we're left with this difference of squares, so we can factor that into those two factors, right? We have roots positive 2 and negative 2, as well as 0 from that initial x that we pulled out. We put those on the number line. We test values in each of those intervals. We end up with negative, positive, negative, positive. We shade the positives, right? Because of course we're looking for where we are greater than 0. We have open roots, right? Those are open points on the roots. So we end up with interval notation negative 2 to 0, both with parentheses, union 2 to infinity, and that's it. Okay, that's all I have for y'all today. Hopefully polynomial inequalities are not too confusing because they are so similar to quadratic inequalities. So hopefully this is kind of a refresher. Thanks for watching.